Now exercise 1.3. Question number 1 is that prove that root 5 is irrational. We have to prove that root 5 is irrational. Solution. Let us assume to contradict. Let us assume to contradict that root 5 is rational. Root 5 is rational. Therefore, we can write root 5 is equal to a by b. Here, HCF of a and b is equal to 1. A and b are in its simplest form. A and b अपने simplest form में हैं and b is not equal to 0. Now squaring both sides. Squaring both sides, we have whole square of root under 5, that is equal to whole square of a by b, or 5 is equal to a square by b square. Therefore, a square is equal to 5b square. Since 5 divides a square, therefore 5 divides a. Equation first. Let a is equal to 5c for some integer. Therefore, a square is equal to whole square of 5c, that is equal to 25c square. Now, putting the value of a square, we get that 5b square is equal to 25c square, or b square is equal to 25c square will be divided by 5, and 5 cancels 25 by 5, that's equal to 5c square. Therefore, b square is equal to 5c square. Thus, 5 divides b square, therefore 5 divides b. Equation second. From equation first and second, we get that 5 divides a and b both, 5 divides A and B both. Hence, HCF of A and B is equal to 5. This contradicts that root 5 is rational. This contradicts that root 5 is rational. This contradiction has a region. This contradiction has a region because of our incorrect assumption that root 5 is rational. Therefore, root under 5 is irrational. 5 is irrational. Now, question number 2 is that prove that 3 plus 2 root 5 is irrational. Solution. Let us assume to contrary that 3 plus 2 root 5 is rational. Therefore, three plus 2 root 5 is equal to A by B, where HCF of A and B is equal to 1 and B is not equal to 0, or A by B is equal to 3 plus 2 root 5, or A by B minus 3 is equal to 2 root 5. 3 का साइड चेंज किया गया है, इक्वल टू के पहले आया तो इसका साइड चेंज हो गया, पॉजिटिव था और निगेटिव हो गया, और प्राप्त हुआ A बाई बी माइनस 3 इक्वल टू 2 रूट 5. नेक्स्ट स्टेप, A बाई बी माइनस 3 इज इक्वल टू 1 बाई 2 इज इक्वल टू रूट अंडर 5, और A बाई 2b माइनस 3 बाई 2 इज इक्वल टू रूट अंडर 5. Clearly, it is clear that A by 2b minus 3 by 2 is a rational number. This is equal to root under 5. Hence, root under 5 may be a rational number. But we know that root 5 is an irrational number. Root 5 is an irrational number. This, this contradiction has a reason due to our incorrect assumption. Incorrect assumption, that is that 3 plus root 5 is rational. Therefore, we can say that 3 plus 2 root 5 is an irrational number. Proof. Now question number 3 is that prove that the following are irrationals. Question number 1, 1 by root 2. Question number 2, 7 root 5. And question number 3, 6 plus root 2. Firstly, we have to solve question number 1, that is 1 by root 2. 1 by root 2. Let us assume contrary that 1 by root 2 is rational. Therefore, one by root 2 may be written as in the form of a by b, where b is not equal to 0 and HCF of a and b is equal to 1. Means a and b are in its simplest form. A and b are in its simplest form. Now squaring both sides. We get whole square of 1 by root 2 is equal to whole square of a by b, or 1 by 2 is equal to a square by b square. Then 2a square is equal to b square. Thus, we can say that 2 divides b square, hence 2 divides b. Let b is equal to 2c for some integers. Therefore, b square may be written as whole square of 2c, that's equal to 4 square. Now, putting the value of b square, the value of b square, we get 2a square. 2a square is equal to 4c square, और a square is equal to 4c square by 2. So 4 cancel हुआ 2 times में, that's equal to 2c square. A square is equal to 2c square. Hence 2 divides a square. Therefore, 2 divides a equation 2. From equation 1 and 2, we get that HCF of A and B is equal to 2. This contradicts our assumption that 1 by root 2 is rational. Therefore, 1 by root 2 must be irrational. Let us assume to contrary that 7 root 5 is rational. Therefore, 7 root 5 may be written as A by B, where B is not equal to 0 and HCF of A and B is equal to 1, or root under 5 is equal to A by B into 7. That's equal to A by 7B. Then root under 5 is equal to A by 7B. It is clear that A by 7B is equal to a rational number. Thus, root under 5 is also a rational. Also a rational number. This contradicts that root 5 is irrational. This contradiction has a region. This contradiction has a region because of our incorrect assumption that root 5 is rational. Therefore, therefore 7 root 5 is irrational. Proof. Now question number 3, that is we have to prove that 6 plus root 2 is irrational number. Let us assume to contrary that 6 plus root 2 is rational. 2 is rational. It can be written in the form of a by b, and a by b is equal to 6 plus root under 2, where a and b are in simplest form, in the simplest form. And a CF of a and b is equal to 1 and b is not equal to 0. Or a by b minus 6 is equal to root under 2. Clearly it is clear that a by b minus 6 is equal to rational number. From equation 1, root 2 is also a rational number. This contradicts the fact that root 2 is irrational. This contradiction has a reason because of our incorrect assumption that is that 6 plus root 2 is rational. Therefore, we can say that 6 plus root 2 must be irrational. True.